Hey y'all, welcome to this presentation today for grading optimization for Civil 3D. This is a new tool of Civil 3D with the 2022 release. We also saw some changes to it with 2023. And the goal of this presentation is to really give you a high-level overview of the concepts to use this tool. If you understand the concepts, then you'll be able to apply them in a wide range of ways to meet all your grading needs. So this presentation, I'm going to try and keep it about 30 minutes. We're going to stay in PowerPoint the whole time. It's about 30 slides. So we'll try and keep it about 30 minutes and just try and give you a lot of value here to use this product and start incorporating it with your design. Okay, so today's agenda, we're going to break this up into 6 parts. So part 1, we're going to do an introduction to grading optimization. Where's the interface? How does it look? What are all the tools that are used for it? And then we're also going to go into each tool and discuss the situations you would use it. So part 2, zone creation, what you're going to find is grading optimization is all about zones and how they interact with each other. Third, we're going to look at pond design. What are the pond design parameters and how does that work from Civil 3D grading optimization? Parcels and building pads, parking areas, and some tips and best practices for using this product. Okay, part 1, introduction to grading optimization. So grading optimization, it's a preliminary terrain optimization tool for designers. So one thing that grading optimization really helps you do is that you can start your grading designs earlier in the process. And one thing it does is it uses an algorithm called an optimizer to create service based on defined constraints and objectives. So one thing you're going to hear a lot about grading optimization is you don't need to have set concrete parameters to create your grading. You may have an idea of certain regions maybe tied to specific points. Say you have a corridor created or something like that and you want to tie into that. But for the most part with your design, you can work with these ranges, so to speak. And we can have a max slope of 33% here or something like that. That's how the ranges will work in the grading optimization tool. So one thing it does, it eliminates manual grading tasks according to customized constraints. One thing that's nice is it's a very iterative process. You can turn constraints off, you can turn constraints back on, you can change the constraints and re-optimize. And every time you finish the optimization process, you have an option to send that surface back to Civil 3D. So you're not stuck or dead in the water, so to speak, if you have to make large global changes to your model. You can all do it on the fly as you're iterating through your designs. Okay, so the ability with grading optimization is you can officially create multiple grading design options. Like I said, every time you run the optimizer and let it cook for a bit, you can send a surface back to Civil 3D. You can easily modify constraints, turn constraints on, turn constraints off, make the constraints a little bit more strict or less strict. It's all easily done within grading optimization. You can identify grading challenges earlier in the design process and identify scenarios minimizing material waste. So because it'll give you more iterations and you can make more decisions based on balancing your cut and fill, for example, it's easier to see like where the problematic areas are going to be for the projects. Okay, grading optimization requirements. So a couple things required in order to start using it. So you need a surface representing your existing grade. You need defined boundaries representing grading limit within the extent of the EG surface. Basically, what sections am I going to grade on this surface? An idea of drainage plan and directions. So one thing that's going to be important is if you know exactly what you're going to do, we're going to talk about this in a minute here, grading optimization is probably not the tool for you. It's more geared for, I have a general idea of what I want. We can loosen these constraints in this area. We may have like a couple set parameters that need to be met, but other areas in your design, you can let the optimizer find the best solution for you. And last thing you need, additional line work. So everything's poly lines in, feature lines out with grading optimization. So all your parameters, building pads, curb lines, drain lines, all your zones are all poly lines in Civil 3D. Okay, like I just alluded to, when to use grading optimization. So in this example, you can kind of see in the background here, it's a fairly straightforward grading process. We got a little bit of cut, we got a little fill, we're grading down from the building pad down to the EG surface. This is probably not the tool to use grading optimization. Maybe use it to evaluate grading optimization and compare it against something you know how it's going to work with previous grading tools in Civil 3D. But with grading optimization, you want to think like, we have some constraints we need to meet, but we're really going to let the optimizer do some work for us. So, and the more freedom you give the optimizer, the better your results are going to be. Okay, the grading optimization interface. Where is it? How does it work? So, with and for these images, some will be in 23 and some will be in 2022. There's some very slight changes with Civil 3D 2023. With grading optimization, we'll discuss what's going to look a little bit different. So for this is going to be 2023. And one thing you notice is right on the Home tab, you have this grading optimization button. And all this is doing is really just creating awareness for this tool. And what it'll tell you, if when you have it installed, you click on it, grading optimization is installed, go to Analyze Grading Optimization to find it. So Analyze tab, Grading Optimization panel, it's on the far right side. You'll see there's a few different parts to it. There's the grading objects. So that's the objects you set in Civil 3D. You set a zone in Civil 3D. That's going to be a grading object. And then you have the Optimize button. So Optimize, that will launch the grading optimization window to run your grading solution based on those grading objects you set in Civil 3D. And the last thing that's here is, and this is new with Civil 3D 2023, is the Help Center. So the Help Center is great because it really gives you good suggestions for how to set up your models to use grading optimization. And it's a pretty smart tool that it realizes where you are in the process. So workflow, create or open a drawing with a tin surface. And so it gives you an idea of just what the general steps are to work with grading optimization. There's also some helpful links to prepare your drawing, workflow, helpful videos and tutorials, and what's new. So it's definitely just, when you get started with this, if you haven't used it, definitely go through the Help Center and just try and understand what resources are available to you. Okay, the grading optimization layout. So this is what we were just looking at. Now we're just a smaller screenshot of the grading objects. So there's two different parts. There's the grading object tools. So these are all the grading objects you can create for your design. And so you can see like the first one, for example, is low point, or the second one is bounded point. And these are all a group of points, lines, and zones, which would be a closed polyline. And once you have set one in your grading object tools, so for example, you want a low point, you click on the low point option, and then you go select your low point in your Civil 3D model. Now it'll go into your grading object browser. Basically, this is everything that's existing set as a grading object. So every grading object you set will go into the browser. And you'll see a number after the name. So for example, building pad, you'll see parentheses 1, indicating that there's one building pad you set in your drawing. Okay, so let's say we set a few different grading objects in Civil 3D. Now we're going to go into grading optimization and we're going to run our design, or run the optimizer to create our potential, maybe our final design. So grading optimization window, far left side, grading objects. So this is the grading objects browser that you had in Civil 3D. It just gives you a list of all grading objects that are for the design. And one thing that's a little different with this spot is you have the option to turn them off and on. So you can only run. So say you have 10 zones and you only want to run 8 of them. You can turn 2 of them off and hit the optimizer, and it'll negate those 2. And the other option you have here too is to turn them off. So if you're not running them, you can turn them off visually so you don't see them as well. Okay, in the bottom left, that question mark, we're going to go from bottom left to bottom right here with all those interface buttons. So this is the help. This gives you the general help for using grading optimization. That little eye with the circle, that's just the build you're currently on. So if you want to check, like, am I on the latest version? This is where you're going to see what build you're on. That little gear, this is your preferences. So this is user preferences for using grading optimization. So there's a couple general things that it can it'll attempt to accomplish in your designs. So refine the surface, mesh quality, you can set it to low, medium, or high, and you can set up your customized max triangle size. So say you wanted smaller triangles in your finished outputted surface, this is where you could set that. Okay, the visualization toolbar. So this is, think of this as like a style. So when your optimization is running, or you paused it after it was running for a bit, you can click on these parameters and see how the model is shaping up. So for example, you can see the hydrology, where the water is going to flow, off your finished grade surface. You can also see the violations. So a violation is when a constraint can't be met. So say your max slope in your zone is 33%. Say it could get to a slope of 40% in one spot. That's going to be a red violation. The slope's too large based on the constraint. So, and there's a couple other tools in here as well. You can see the topology, you can see the triangles, you can change the theme too. So this one's a pretty colorful theme you're seeing, but you can also you can make it a less colorful grayscale if you wanted to. Okay, the convergence plots, and these are a little bit different with 2022 to 2023. And so this is 2022, and then I'll show you what you're going to see a little bit differently in 23. So basically with the convergent plots is there's three, and these will populate as you run the optimizer. There's three different that are running at the same time. There's volumes, there's terrain smoothness, and there's the proximity measure, which is really the feasibility of your design based on your constraints. And the one to really pay attention to is the proximity measure. So what this really indicates is how far along the optimization is, how far it's along to finding a solution. So you'll see it drop down this logarithmic scale, and as it pans out, it will eventually just really create a flat line. That's when you know the optimizer's pretty close to finding a solution, or it's not really changing too much anymore. One thing you'll see is it's the law of diminishing returns. At the beginning, you'll see that surface move up and down and move all over the place as it meets those constraints, and then towards the end, it's just making small tweaks here and there. So what you're going to want to pay attention to is it dropping down? It might go up and back down, up and down, but for the most part, is it creating that bell curve and panning out? Optimization options. So this is where you can set global constraints. So say you want to have a max slope of 33% everywhere, you could set that in the options. The number of iterations, so this defaults to, I believe that's 100,000. And what that means is it's going to run 100,000 iterations before it finds a complete solution. One thing you can do here is you can decrease the iterations. So say, for example, drop it down to 10,000 when you're iterating and you know that this surface is probably not going to be your final design. You can drop the iterations down so the optimizer will run a bit quicker and just see if you're looking for a specific red flag or you're trying to just figure out one specific spot, drop the iterations down so it'll run a bit quicker. And then last thing, objective weights. And we're going to talk about these a little bit more in depth, but basically what this is what is the optimizer going to focus on? Is it going to try and balance cut and fill? Is it going to minimize earthwork? Is it going to smooth the surface? These are all independent of each other, so it's not like they all add up to 100%. But if you want to really focus on balancing cut and fill, you can increase the focus for that. Keep in mind, all three of these things are objectives. So what that means is the optimizer is not constrained to them. The optimizer will do its best to meet these objectives, but it's not a make or break situation. So for example, what you'll see is a constraint like a max slope. That is a make or break situation of the optimizer. It'll give you a notification that this constraint can't be met. With the objective weights, it's not going to do that. Okay, optimize, hit that play button, and that's when you'll see the convergent plots drop, you'll see the contours on the surface change, and that's when the optimizer is iterating through different solutions. And then send optimized result. So you don't need to do this every time. Once you run your optimization, you're probably not going to send a surface back every single time you try a different idea or a different plan. So, but when you do, this is what you're going to see. You're going to have a couple of different things that'll go back. So you're going to have your surfaces. So it's going to be an XML surface that goes back to Civil 3D. Ooh. Then you're going to have feature lines. So every 2D polyline that you created a grading object with is now a 3D feature line, and that's going back to Civil 3D as well. And last thing, points. So any points created, low points, bounded points, those are going to go back as a COGO point to Civil 3D. You have an option to set the style. You have an option to give the surface a name. You could update a surface if you wanted to. So say you had a surface you kept on making small changes to, you could send it back and update that specific surface so you're not constantly creating new surfaces in Civil 3D. Okay, this is what is going to look different in 2023 versus 22. So one thing on the bottom is you're going to have an enhanced status bar. So what it used to do is it just go straight across in a straight line. It didn't have all these check boxes it showed you. So what this really shows you is how close it is getting to the solution, and it gives you a better idea of how the optimizer is running during the process. So when it ran in 22, you weren't quite sure where it was at. and was it getting close to a solution? You could check the convergence plots to give you an idea, but it wasn't giving you checks along the way that it was for how it was processing things. Next thing, notification center. So if you have any error messages during optimization, you'll see them there. Optimization. So there's some little slightly updated graphics. So one thing that they changed is they changed the max and mid slope. So colors. So they used to be red and a lighter shade of red, and it was a little too close to each other to you get confused which one's which. Now it's red and blue, so it's a lot easier to see when a max slope violation is violated or a min slope violation. And then darker red, multiple violations. Convergence plots, it gives you this little preview. It's kind of like maybe like a surface preview in Civil 3D. And one thing, so you don't have to open up those convergence plots to see it. And one thing that's also nice about it is it gives you an idea of how close it is to finding a solution. So you can see at the beginning it starts out with orange. That means it's iterations required. We're still trying to find the solution. Then towards the end, you're going to see red or green, indicating your solution is going to work, or red, indicating there's something you need to check out. Last thing, help center. So like we just looked at in Civil 3D, there's a help center within the grading optimization as well. The help center in grading optimization will give you suggestions based on where you are in your optimization process. So one thing that's nice about it is that it realizes you're already in grading optimization, so it's not going to tell you how to set grading objects there. It's going to tell you how to review your optimization options and how to begin your optimization. So definitely, as if you're newer and checking this out, I would recommend checking out the Help Center just to understand workflows and see what resources are at your disposal. Okay, part 2, zone creation. This is in my opinion by far the most important thing, and the most important thing to understand with grading optimization. So there's a few different grading objects. It's a bit intimidating at first, but you'll find they're actually they all really relate to each other. So once you get the idea of a couple, they're all gonna make sense. So points. There's 2 types of points. There's a low point and a bounded point. So generally, a low point, use maybe a low point at a spot in a pond. Bounded point, that can be a fixed elevation, or it can be a range. So like it has to be at 5 feet. Bounded point, or it can be at a range of like 4 feet to 6 feet. Lines, so any sort of lines, so basically it's just not a connected shape, square, triangle, it's just a line. And there's a few different lines. There's aligned edges, bend lines, drain lines we're going to talk about. Those are very important. Elevation offset, curves, and reveal. So reveal would be on a building pad if you're trying to show or hide an elevation. Last thing, zones. So and all zones are the same, they just have different predefined parameters. So the general zone, exclusion zone, ponds, curbs, grading limit, parking lot, sidewalk, accessible path. We'll talk about how they're all a little different in a bit, but just keep in mind zones are those closed polygons in some way, shape, or form. And last thing that's not on this screenshot is retaining walls. So a retaining wall can be a zone or a line. Okay, points. Just a brief description of each of these. So a low point is a grading object that has an element controlling the direction of drainage. Example is a low point in a pond. A bounded point. A bounded point is a grading object that creates an elevation constraint or range. A constraint, the surface must be equal to a certain elevation. So say your elevation needs to be 4 feet in one spot. This can be useful if you're using, if you have a corridor that's already been finished, and then you need to tie in your parking lot to your corridor. You use a bounded point so that that surface will meet at that corridor. Okay, lines. A lined edge basically just creates a break line on the surface. Bend lines, these relax the triangulation of the surface or the slope of the surface, basically just to relax, reduces earthwork. Drain line. So that's what direction is the drainage on my surface. So, and it's the drain lines work in direction they're drawn. So vertex 1 to vertex 2 is how it's going to drain. Elevation offset. This controls the elevation difference between a start and end point. So say your building pad needs to be 5 feet, but you have a entrance that's at 0 feet. You can use an elevation offset to make sure there's a 5 foot difference between them. Curb. Those could be open or closed, so a curb island or just a curb around a parking lot. And they can be reversed as well for the high side and low side. Reveal controls the visibility of a building pad. can be positive or negative. So if you wanna force the building pad to show, if you want to force the surface to show some of the foundation, maybe you got a lower floor with you're planning on installing some windows, or you can do the opposite and make it negative and actually hide more of that foundation. Last thing, retaining wall, open, closed. They work very similar to curbs, with the light shade is the lower, dark shade is the higher side. Zones. So zones are areas of site with specific grading requirements. So max slope and min drain slope. Exclusion zone, basically just an area that you don't want to have optimized. Ponds, and that's just a surface area, range of ponds, detailed slope constraints through parameters. So there's different things you can set for ponds. So you want a wet pond, dry pond. One thing you can do with pond zones is you can let the extent of the pond change to meet volumetric requirements. So say your polyline's a circle, it might actually make your circle a little wider if you enable that. Curb, closed geometry to create islands. Building pad, all this does is flattens the area and meets elevation constraints so that that surface will slope up to the building pad. Grading limit, this is the outermost footprint of grading. So this is basically your extent of your project. And you can set generic constraints for your grading limit. Parking lot, pre-configured zone with a default depth of material. Sidewalk, pre-configured zone with a default depth of material. And accessible path, pre-configured zone with required slope constraints. So one thing you'll notice is parking lot, sidewalk, accessible paths, very similar to each other. Okay, zones hierarchy. This can be a little bit confusing, and it's important to understand how zones work within each other. One thing you'll see here, this is in the grading optimization window, is the zones are all listed together. So you can see at the top there's green space, then you have sidewalks, then you have roads, then you have some more sidewalks. So, and those can be an accessible path sidewalk or just a general sidewalk, but they're all together. So, and how they work is that it's a hierarchy. So the zone on top is going to be the most important. And what I mean by most important is that within that region that zone holds, that max and min slope is going to be the priority. So you can see in this screenshot here, we have a few different zones. We have zone A, which is green, zone B, which is blue, and then the grading limit, which is that yellowish color. And you'll see with that picture on the right, that 17% max slope is the one that's governing. Even though that the say like 5% slope is less, and in that overlap region, the optimizer will default to the 17%. So just keep in mind that the hierarchy of the zone is important for which one is doing what in which area. Difference between a constraint and objective. So most grading objects create constraints. And constraints are max slope, min drain slope. So you have a max slope in this zone of 33% and a min drain slope of 2%. There's a couple different now. So that'd be a constraint. The grading optimization tool is going to meet these constraints. This is the same thing with the building pad. So you set your building pad, you set an elevation. So in this instance, we set an elevation range, and it's going to meet that constraint. The elevation of that building pad is going to be somewhere between 0 and 999 feet. Level grading with pad. This is an objective. So it'll try and level the grading with the pad, but it might not meet that. So what the optimization is going to do is that's going to be a nice to have, but the grading optimization is not going to prioritize that. This is the same thing with the grading optimization options. So balance, cut, and fill. If you set that to 100, yeah, it'll look at it and try and balance the cut and fill, but that's not a constraint that it's going to meet. So one thing to always keep in mind, the constraints are paramount to the objective. So constraints must-have, constraints are must-haves, objectives are nice-to-have. Drain line and minimum drain slope. So this can be a bit confusing. So min drain slope. This works with drain lines or minimum zone inclination. And one thing you can do is alternatively, if you don't want to have any drainage on your site, just set to 0 to avoid it. So you'll see that. So in this zone properties, the min drain slope is 1%. So that means the min slope on that surface is 1%, and it's going to drain towards a certain direction. Exclusive drainage. When enabled, drain elements are only within its zone and not to other zones. So say you have a parking lot and you have a drain line within it, everything's going to drain towards that drain line. Set to exclusive drainage, that zone will only focus on that drain line. It won't see any others in other zones. Minimum zone inclination. So say you want everything to drain in a certain direction. And so you just enter a degree value for the direction of the zone to slope, and it's all going to slope in that direction. Drain lines. Polylines drawn in direction of intended drainage. So generally high to low, and surface triangle will angle to the nearest point of the drain line. We're going to talk about the surface triangulation in a second. And one thing as well, drain lines can reside outside the extent of the grading limit. All the drain lines really do is just provide the direction for the hydrology. So if you have a 1% and you have a drain line there, it's going to slope 1% towards that drain line. Drain lines and minimum drain slope. So we have 3 screenshots here. So we're going to work left to right. So first thing, generic surface. So just picture a surface. There's at every triangle we have a point, and we have like 15, 20 triangles here. Now, in that middle picture, there's a blue line going north-south. So that's your drain line. So let's say we're trying to drain in that direction. And what that'll do is the surface will slope towards that drain line. So it's going to drain from that, for example, that yellowish triangle on the right. It's going to drain from right to left. And that surface is going to be angled towards the drain line. So, and this is the case if the, if the surface triangle is above the drain line, it'll angle towards the end of the drain line. And one thing it'll always do is it always takes the shortest distance to the drain line. So say you have a couple drain lines, it'll pick whichever one's closer. So try and picture, like, say you have a drain line on each side of a road, that crown that's in most roads, that's how drain lines are going to work. If you have a drain line on each side of the road, it's going to create a crown, and it's going to go, one side's going to go to the closest to the left, and the other side's going to go to the closest to the right. And you can see in this picture here, that's the result. So you can see it'll find the shortest distance it can to get to that drain line. Okay, pond creation. So ponds are fairly straightforward to create. There's about 10 parameters to input, and most of them are pretty flexible in terms of you don't always actually need certain constraints if that's not part of your design. So dry pond, wet pond. So dry pond retains water to discharge it. Wet pond, some volume of water is sticking around in that pond for most of the year. Storage volume. So these are the parameters to control size, and you have the ability to move based on volumetric constraints. So you say you have a circular pond, and the min storage volume that you input is just it's way too large based on that circle you created. It'll enlarge that circle to meet those volumetric constraints. Okay, berms. So this is just the incline to the rim of the pond. Freeboard distance between max water capacity and elevation at the top of the berm. One thing that I like about with these slopes here is they actually are in a slope, so like 3:1, versus they're in grading optimization. So when you see like 33%, 3:1 slope, it's nice for the pond tools that it's actually a slope. Safety bench. So these are just low angled with minimal depth for access. You can see there's a diagram too, and it gives you a nice little reference. So like D, E, and F, where do they relate to in that diagram? Okay, parking lot design. So these are all the zones that relate to parking lots. And what I'm going to show you here is they're all very similar to each other. They just have different start constraints. And that's really all it is between them. So say we create a parking lot. Customized slope constraints. For my parking lot that I create, my max slope is going to be 5%. My min drain slope is going to be 1%. And one thing that's already set in my parking lot is that it's exclusive drainage. So it's just a couple of parameters that have been preset for me, and it kind of generalizes where parking lots generally are in terms of max and min slopes. Sidewalk. This one defaults to the same slope. You can see one thing that it does is it does a minimum zone inclination. It's going to drain all the hydrology in one direction. That's already automatically set for me. And the depth of material is set as well. Accessible path. So these are going to have a smaller max slope. So you can see here we have a 2% max slope, 1% min drain slope, and our depth of material is 1.5 feet. And then just a generic zone. So A generic zone is going to have broader constraints. So max slope at 33%, min drain slope of 2%. And you can see that none of the aligned surface, exclusive drainage, minimum zone inclination are turned on. And one thing that can be created from a generic zone as well is you can create a grading limit. So at the bottom there, you can turn the grading limit on, and that'll be the extent of your design. Okay, just as we talked about with the hierarchy within Go, all of these go to the same place. Parking lots, sidewalk, accessible path, a generic zone, they all go within the zone grading objects when you're optimizing. So one thing that's important to remember is give them all a distinct name, because they're not good. For example, sidewalks are not going into their own sidewalk bucket. So it's important to make sure everything is named correctly so you can find it and you're not spending time searching around your model. And the next thing too is that's how that hierarchy process works. So when you zones on top of zones on top of zones, the zone closest to the top is the one that's going to take precedence. Curb properties. So these work separate than zones for parking lot design. So curbs can be a closed polyline, or they can be just a line. So you'll see when you create one, it'll give you height and width. It does default to 0.2 feet from European, 0.2 meters. But so you can change those properties to say half foot is generally standard. You want to make that half a foot for your height and width. And one thing that you'll see is that the colors it's like one side's dark and the one side's kind of got this lighter side. So dark blue's the outside, lighter blue's the inside edge, and basically what that is the high and low side of your curb. Reverse curb, so you just select that and it flips the high and low side. And like I just said, they can be closed or open polylines. Okay, part 5, parcels and building paths. So keep in mind for there's no parcel grading object set when you're creating. So that it'll just be a general zone for your parcel. You could name it parcels if you want to for a specific zone with specific constraints, so that you have a parcel option in your grading object browser. So, but just keep in mind, this is primarily just adding in a building path. So building paths. These are objectives. The level grading with pad, as I previously said, is a objective, not a constraint. So it'll try to. So you can see on these screenshots here, the level grading with pad has been set on, and you'll notice that the foundation wall isn't flush with that FG surface. And one thing you can use is you can use a reveal and set the elevation to 0. So reveal hides or shows the elevation, and if you create a reveal and set it to 0, that'll now it's a constraint that the surface needs to meet. Okay, tips and best practices. So a couple of things impacting performance. So grading optimization is tied to the number of triangles, not the size of the lot. So you can have a large lot with 4 or 5 points and only a couple of triangles, and that'll work much faster than a smaller surface that has thousands and millions of points. So say you had a point cloud, that's going to be slower in grading optimization than a surface with larger triangles. Visualization displays. These can slow down performance, so the more visualizations you have, the slower it can get. So one thing you'll see here on this screenshot is I have the triangles on and I have the hydrology. And the hydrology is going to put an arrow in every single triangle, and that could bog things down, especially if you have if grading optimization is using a lot of your available power on your computer. Adding grading objects with grading optimization open. So if say you're in Civil 3D and you want to add a different grading object, say you want to create a new zone or something, that's not automatically going to transfer to grading optimization. You got to close and reopen it or to see that grading object be added. Export to Civil 3D. So again, those 3 options: surfaces, feature lines, and points. So your surface is going to be an XML surface. And another thing important to understand is the surface extends to the area of the original surface. It's not the area of your grading limit. So say you create you have your EG surface and you only grade the bottom left-hand corner of it with a grading limit, that entire EG surface is going back to Civil 3D. Update existing surface for iterations, multiple grading limits. So say so you on that right side there and you click update existing surface, you could update when you created. So say you have one with multiple grading limits, you can just do a portion of it and send it back, and then do another portion of it and send it back versus doing the whole thing at one time. Feature lines. These are created from grading objects, so 2D lines in, 3D feature lines out. One thing that does happen is there's a lot of vertices with the feature lines, and you're gonna want to weed those out when you get back to Civil 3D. Points, and these are just points created during the optimization process, those low points or those bounded points. Okay, a bit of additional content that I've found to be very helpful to learn this tool. So, and all of this is free to use and accessible off the internet. So, a couple AU talks, Handyman's Guide to Grading Optimization. And there's another one, Grading Optimization for Civil 3D. This is led by John Stair at Autodesk. It's pretty good. It's very high level, so it gives you a good idea of just how the tool works, but not so much getting into the real nuts and bolts. There's also been these Grading Optimization Live, Part 1, Part 2, Part 3. I think it's a 5-part series. And this is with the project manager, Charlie Ogden. And one thing, this does get in the nuts and bolts, and I find it to be very well done. So if you're learning the tool and you want to ask the product managers about questions about using it and whatnot, definitely tune into these because they're very helpful. Okay, this takes me to the end of my presentation. I hope you got something out of this. I hope this was helpful. If you have any questions you want to talk to me about using grading optimization, definitely don't hesitate to reach out. My name is Nate Philbrick, and my email is nphilbrick@topconsolutions.com. Thank you for your time.